was the reason to your answer. So nice. So yeah, what I wanted to write was, I guess another point is that currently CO2 is at in the atmosphere. You guys don't have to remember this. I'm just writing it down. Hey, like this is today. It was, I checked this morning, 409 ppm, and this is interesting because I'll show you some graphs later, and then it'll make sense. But let's get to some data on how we know of CO2. So yeah, let's write the proxy records. So we know what's it called? We know the amount of CO2 through time, and I'm going to show you that was past like 50 years, right? So air CO2 corresponds to about 50 years, right? And now these ice cores that I'm going to show you, they actually correspond to the past 400,000 years. And this number was actually determined because carbon dating can only go back about maybe 50 to 100,000 years, but they extrapolated linearly across the ice core. And so the first 50,000 years, they show like a linear change in the isotopes through time, and they just extrapolated that to the rest of the ice core, which they said was, okay, it goes back to 400,000 years. So. And so what these are is they actually go into like Antarctica and glaciers, and they actually drill into the ice, and they take out this like core of ice, and it's actually stratified, and based on oxygen isotope levels within the ice core, they're able to determine past carbon dioxide levels and temperatures up to 4,000 years ago. So it's called a proxy record, which could be represent like a replacement record, right? They're not actually measuring temperature. They're using isotopes, using like oxygen isotopes, the percentage in each strata to determine the amount of CO2. So I guess that's just the oxygen level. What this represents in terms of temperature. So this graph is like, this is the main one that kind of, in my opinion, really shows that there probably is a very strong global warming effect due to carbon dioxide, because on the top you see this is carbon dioxide over 400,000 years, and this is temperature. And we can see is that they're like pretty much almost exactly correlated, like a perfect correlation through time, right? And if you look at this graph, right, you see the CO2 at 300 parts per million, and what did I say we were at? We were at 409. So that means we are way up here in terms of CO2, right? Like way up here, I think. Whoops. Can I go back? I can't go back anymore?
Yeah, just hit back on the LP.
Yeah, so like we are currently today, so this is even an old figure, right? Because we're at 409 today. So we are like up here. And I mean, if based on inductive reasoning, right? Like if you look at temperature, it's such a strong correlation, you would also predict that the temperature would also be high. And we do see that, and I'll show you in more relevant records. So this figure alone, I think, really just should be shared everywhere, because it really shows the direct correlation of temperature and carbon dioxide. So I mean, any what's it called, things said by anyone that doubts I guess the effect of carbon dioxide and global warming, just show them the data. That's it. Be objective, right? That's my opinion. And so this is just one thing. That's why I wrote ice cores. Gosh, I couldn't even write it straight. And to go back, actually, you can see that there's cycles. And does anyone know why there's some of these up and down cycles through time? Yes, sir. Your name?
Seasons again?
Yeah. No, not seasons. It's not this time.
Oh.
It's kind of related.
All right.
And your name, sir?
Spencer?
Sorry?
Spencer?
Spencer? Nice to meet you, Spencer. Nice. It's kind of related to seasons a little bit. I don't know if you can read the x-axis, but what the numbers are, it goes like, so like this is like 50,000 years, it's another 50,000 years. Anyone can, yes?
The temperatures between each year that go by?
not between each year, but between like um, actually much longer, like
Much bigger years.
yeah, much bigger. But does anyone know why? What happens every? Do you know what happens every like 10, 20,000 years? Eric was first. Sorry, yeah.
I'd assume it's just something where a planet blocks out type of sun, like.
It's close. It's really you're getting really, really, really close. You're like right on the verge. Yes, sir. Your name? The ozone layer? No, that's a good guess, but I would say the ozone layer was more a recent depletion in time. I guess over the past 200, 300 years with development of like fluorinated carbons and other stuff by humans. But no, it's close to what Eric was saying. Sorry, your name? Jack. Good guess, Jack. But that's more it's more a recent type of thing. Anyone else? Yes, Eric again.
Is it the moon?
Sorry?
Is it the moon?
It's really yeah, it's really related. It's really close. You're like really almost there. Yes.
Planet alignment or the eclipse.
Okay, yeah, I gotta give it to all of you because you all got it right. It's mainly due to like the ice ages and yeah, like the planet alignment for sure. And what I guess every 23,000 years the Earth like shifts its like axis a little bit. Like it changes. I don't know how many degrees. I don't even know if it's written there. But anyways, yeah, it's called like the Milankovitch cycle, and every 23,000 years, the Earth like changes its axis from like 23 degrees one way to 23 degrees the other, and it creates these like ice ages, and in that there's right the Earth is almost encapsulated in ice, and yes.
So like if we end up driving for that long, you just might not finish.
Yeah, possibly. Yeah, it is a very real possibility. Based on like past information, yes, I would say so. But then you got to remember.
Mark, is it just like a sudden shift? Because I know the Earth like wobbles as opposed to being like spinning on like a finger. Like, does it just slowly work its way the other way, or does it all of a sudden is it just like boom?
No, yeah, it's a slow, gradual, yeah, change. Yeah, I think it's yes, yes, you're saying.
What causes it to turn?
I don't know, to be honest.
Is it a gravitational pull?
I think I think it's a great guess. I'm sure it has a lot to do with that. To be honest, I don't know. I think it's I'm kind of imagine it like a when you spin like a top, like there's the rotation of it, and then like around a place, and then there's the wobble of the top, and then like I think the wobble is kind of like these Milankovitch cycles, right? So like the Earth is spinning, and it's spinning on itself and around the sun, but it's also wobbling over like thousands of years.
So kind of like maybe like I know when you hit like when you do that spin wobble, something hits it like maybe it's caused from an eclipse. It'll like
yeah, possibly.
And then from the gravitational pull that's supposed to go around in a circle, it'll kind of like spin back into its spot.
That's actually a really great idea. I don't know. I'm sure, but like I'm sure it's been studied, but I don't know the answer to that. I think that's a really great. Yeah, I mean there definitely is an explanation or a theory for that. I think it's a great one. I think it's probably very accurate too. But yeah, okay, nice. Let's move on, I guess. So these are just the locations of the ice cores. There's a lot of locations, right? There's a lot of work that's done in Antarctica. Very grateful for this work. I chose to work in tropical forests, a little different, a little warmer. So, sorry? A little warmer, yeah, just a little. But I'm really grateful. They share this data online. I actually use some of this data for my research. So, I wanted to show this figure because prior to 400,000 years, the CO2 record and temperatures actually aren't correlated as well as they have been over the past 400,000 years. But you also have to take this figure with a grain of salt. I'm not explaining. I'm not saying, or rather, I'm not providing like an excuse. I'm just saying that some